Welcome to the Foundry by Forge College. Now that you've successfully navigated the deployment checklists for Solana, we can turn our attention to the actual economics of what we're building. Pricing a token is about more than just picking a number. It's about creating a set of rules that governs how people behave, ensuring that one or two very wealthy buyers don't accidentally ruin the party for everyone else. To understand how these rules work, imagine walking into a stylized farmer's market. Let's call it Token Town. Here is our market layout. We have 3 different vendors, and while they're all selling the exact same digital asset, each one uses a completely different logic to set their prices. Deciding which of these stalls represents your project is a primary way for a developer to shape the demand for their token. This graph shows the approach of stall A, flat pricing. The price is locked at 10 cents per token, staying there regardless of volume. The math is predictable. $10,000 gets exactly 100,000 tokens. It's highly transparent and simple to code, but that simplicity has a downside. Since there's no mechanism to slow anyone down, a single person with a lot of money can easily buy out the entire stall before anyone else gets a chance. We call this the crypto whale problem. Without a rule to prevent it, one massive buyer can sweep the entire inventory in a single transaction. So while flat pricing is easy to understand, it doesn't offer any protection against someone hoarding the entire supply. Now let's look at stall B. This vendor uses linear pricing, which operates a lot like a ticking clock. By this rising green line, the price moves up steadily. The longer the sale lasts, or the more sold, the higher the price goes. This visible rise creates a natural urgency, rewarding early buyers with a lower price, while latecomers pay more. In our other Forge College programs, we talk about how this requires the code to keep a very close eye on the clock, or maintain a perfect count of every token sold to ensure the price stays accurate. Linear pricing is a great way to reward your earliest supporters, but it does put more responsibility on the developer to track those changes correctly. Finally, we have stall C. This vendor uses a supply curve. Think of this as the aggressive math option that is specifically designed to stop massive buyers in their tracks. This purple line shows the price climbing exponentially. It starts cheap, then takes a sharp turn skyward. Every single token bought makes the next one significantly more expensive. $10,000 here buys only a tiny fraction compared to stall A. Building this in code is more difficult. It requires complex math that is hard for a computer to calculate perfectly without making tiny rounding errors. While these curves are the trickiest to build, they serve as a strong defense against massive buyers and help ensure the tokens are distributed more fairly across a community. Looking at all 3 models side by side, we see the trade-offs. This is the heart of token sale essentials. Flat pricing is simple but vulnerable. Linear pricing creates urgency but needs tracking. Supply curves are great for fairness, but challenging to engineer. As you move further into applied Solidity development, you'll find that the way you write your code will always depend on these economic goals. The pricing model you choose is essentially the blueprint for the community you want to create. To learn how to turn these market metaphors into actual smart contract code, visit forge.college. We have plenty of resources there to help you master this and many other Web3 topics. See you there.